Welcome to the future of Kotlin Talk. But first, let's talk a bit about the history of Kotlin. Kotlin 1.0 was released as a pragmatic language for JVM and Android. And in Kotlin 1.1, JavaScript support was added with coroutines and more features. Initially, you could only share code by copying it, but that changed in Kotlin 1.2 with multi-platform concept where you can share code and also make it platform specific with expect and actual. In Kotlin 1.3, coroutines were stabilized and code sharing entered the new dimension with Kotlin Native, opening way more platforms to Kotlin code. And the recent release, Kotlin 1.4, was focused on quality and performance, while also adding a bunch of new features, of course. Having a look at the history, we can now talk a bit about the future. The new future is easy. It's our near-term plan. That's where we have a lot of clear picture of what we're going to work on. As you can see from the history, multi-platform is a big part of team support, and we're continuing to work in this direction, specifically into Kotlin multi-platform mobile, where we're focused on bringing sharing between Android and iOS, making it easier and bringing it to production quality. But Kotlin's home, where it started with JVM, is still an important focus for the team. We're really committed to improve Kotlin on JVM, which specifically means that we're committed to Kotlin's interoperability, not with the existing Java features, but also with the upcoming features of the Java language. It means that for all the new Java APIs that are going out, you can use them out of the box. And all the Java platform features that are library only, for example, like Project Loop, will be readily available to the Kotlin users. However, Java as a language is also evolving and adding new features. In particular, Java is adding records, and Java is adding sealed classes. And we will be making sure that Kotlin code can interoperate with those as seamlessly as with all the existing features of the Java language. That was near future. Now, when we talk about future further apart, let's talk first and what drives us. How do we figure out which features to work and which features not to work? What we're looking at. And the main thing we're looking at is our community. Because, see, Kotlin team, we're not a very big team. I mean, there are far more of you using Kotlin than us, working on Kotlin. And it's not our language, it's your language. You are the users of the language. So we look at our Slack and forum chats to see what people are interested in. We communicate with our big users directly to see what problems they experience, what needs they have. We look at UTrack, see what issues you vote for, what issues you create, what problems you have. And we also have key repository for language enhancement and design proposals. And this brings an interesting topic on how do we use UTrack versus Keep. What's the best way to use them for? And over time, we figured out that Keep repository works better as a storage for design documents that are worked out, prototyped, and ready to be included in the language. And Keep issues work best for corrections, suggestions, and improvements to those. While for problems, ideas, proposals, the best place to track them is through UTrack. We have a special tag there called language design, and whenever we encounter proposal or problem that people raise with respect to the language, we tag it that way, and that's how we keep track on how many people are interested, what's our ideas, how that can be solved. And specifically, if you look at the language design tag at the UTrack, you'll see lots of success stories where at different Kotlin releases, we've solved problems that were really high voted and were important for many users. For example, in Kotlin 1.1, we've allowed callable references with expression of the length side, and by that time it had 70 votes. That was a big number for Kotlin 1.1. In Kotlin 1.2, we've solved the long-standing problem at that time of our server-side JVM users where it was quite verbose with annotations to write multiple values. So we've added a syntax where you could do it in a more concise way. In Kotlin 1.3, another syntactic improvement that's Kotlin specific will allow you to assign a variable and use it as a when subject in the same line. And that was a very popular feature. And of course, in the most recent 1.4 release, which was also, we're looking at what you're interested in, and we've heard you, and we've closed the problem with single abstract methods for Kotlin classes. In Kotlin 1.4, we've introduced functional interfaces, and that was really high-voted issue. It's actually not the only issue with 200, where there are a group of several linked issues that were all quite big. And we've heard you, and we've closed this problem with Kotlin. So that kind of gives you a glimpse how we work with community, how you look at problems that you post for us and vote for, and how we close them. So now we can take a look at a more distant future, and of course, disclaimer here is everything that I'll be saying after that is just a pure speculation. It's the ideas we're looking at. It's not something we worked out in detail. So I'm telling you just because we are, as a team, we're looking for your feedback. What interests you, what you like, what you don't, what's more important, what less. But what exactly is going to turn out, time will show. To see, we don't have to go far. Let's see at the most voted language design issue right now at Utrecht. What is that? That's an issue which this title, adding static accessible members to an existing Java class where extension. And if we just look at the title of this issue, it's really tricky to decipher because it has, in short, basically, it asks for static accessible extensions, which is kind of weird in Kotlin because if you look at the Kotlin documentation, you'll see that all extensions in Kotlin are resolved statically. So what exactly are statically accessible extensions, if all of them are statically resolved? If we actually read the issue itself, we'll see that the issue itself starts with a proposal. Let's allow this kind of syntax. And what is that? What's being asked here? There is some third-party type, like intent, that the person wanting this syntax doesn't control. It's coming from Android in this case. And we want, but it doesn't have a companion. So we want a syntax where you can say, but I still want to have a name and companion of this type and add an extension to this companion. The problem is not only intent being stored, but it doesn't have a companion object. The code on the right, if you write an extension for a companion, has to receive an instance of this companion as its receiver, as this variable. But we can't make this work for third-party library because if different people will be adding these extensions, they will all end up with a different instance. So when we see a request like that, when it's it lists an idea, but it's not clear how to get this idea implemented, the question we always ask is, what are you trying to achieve? Why do you want this? And in this particular case, the answer is easy. The person who asks this wants to write a type name dot extension name. That's what they're trying to achieve. They want this kind of usage. They want on the use side to be able to say, use a name of third-party type with their own extension name. The syntax they proposed, it was just one of ideas. Not they wanted to achieve is this. By understanding what you want to achieve, actually opens a door for us to better figure out how it can be solved. To start, we'll look at similar or related problems in the language. And in this particular case, we don't have to look far. Let's take a look at the standard library. Standard library has this declaration. It declares object delegates with not null functions. And we can ask why it's declared as an object, why it's not just a top level not null function. Or the same questions, what are you trying to achieve? What standard library designers writing this code were trying to achieve? And they were trying to achieve this kind of use site syntax. They wanted on use sites to read delegates dot not null. That was the intent of this code. You see, it's very similar to this question about statically accessible extensions. But the designers of standard library had to use an object to reach this goal. Well, what is an object in Kotlin? An object in Kotlin creates an instance. You can assign it to a variable. An object in Kotlin creates a type. You can do type checks for it. You can declare variables of this type. And also, an object in Kotlin creates a kind of a namespace. So to enable this kind of delegates.notNull usage. But see, among all of that, we really, in this case, wanted just a namespace. Everything else, an instance, a type, is just a library maintenance burden. We had to add them into standard library in this case, or the same conundrum third-party libraries phase 2. But it just creates now a burden because we now have to support this instance, we have to support this type, even though we never intended to have them in the first place. All we wanted is a namespace. So what if instead of creating a namespace, creating an object, we can devise a syntax that would create just a namespace? For example, add a new keyword, namespace, and say, now you can declare namespace delegates. And it gives you just a namespace. It only enables you to write delegates.notNull and nothing else, no type, no instance. Now, if you take this, a relatively simple idea, and take it further, we can see that it enables the concept of companion spaces instead of companion objects. And this actually solves long-standing problem of making the way Kotlin classes compiled closer to the way they're compiled on JVM, makes it easier to bridge Java APIs with static members because we don't introduce an instance, we don't introduce a companion type here. It also enables us to think about extending namespaces. So instead of extending a companion instance, which has a type and an instance, and we're writing extension on an instance, we can devise a syntax for namespace extension. It might look something like this. Some pseudo syntax where it says, I want to write extension of this namespace to distinguish it with writing extension on an instance. And with this kind of syntax, the code at the right-hand side doesn't have to receive any receiver. It is just like top-level function code. It just, and this way, you get what you want. You can write your third-party type with followed by dot, followed by whatever extension you want it to have, without introducing extra stuff like instances and all this complexity. So it gives you exactly what we wanted and also solved all the other problems in a consistent way. Now let's take a look at the other big issue that also comes a lot in UTrack and actually comes a lot in Keep. There are several Keep issues related to multiple receivers. Now receivers is and functions with extension functions, a unique Kotlin feature, and no surprise that through evolution, people have discovered that they often run into a situation where they want a few of them. How this happens? You see, and this is actually the issue, multiple receivers on extension function property. It's just one issue, and there are lots of related ones. It happens because Kotlin has a feature called member extensions. And with member extensions, you can have a class view, and you can define a member extension in this class. For example, an extension DP on the floor. That's actually a use case taken from the issue. And you see in this code, you have two receivers. One receiver comes from the class, from the extension you write. It's like an instance of a floor. The other comes from the class view in our example. So this extension, being a member extension, has two receivers. One of type view, the other of type float. The challenge is that you can write those member extensions in a class, but you cannot write them as an extension to this class. And this particular issue asks for this kind of syntax. Let's give a comma-separated list of receivers and write an extension. That's what this particular issue suggests. If we also look around, we'll see that people ask for syntax like this, where they want to dot separate receivers, or syntax like this, where additional receivers are given a simplicity parameter. There have been over time, lots of suggestions of what syntax might look like. But none of those syntaxes look specifically Kotlin because they don't resonate with any existing syntactic tradition in Kotlin. They just, taken from other languages or just invented on spot. And so let's try to find what could be a better looking Kotlin syntax for this feature. Let's look for syntactic analogy. And here, syntactic analogy is how we bring a receiver into scope in Kotlin. And we bring it with a standard library function with. When we write with view, in the curly braces, we have now additional receiver that is view, and we can use its extensions. So that would be our best syntactic analogy for multiple receivers in Kotlin. So by taking this idea, we can devise a syntax looking like this, where you have a function that could be an extension function, and you add additional receivers by saying that it should be called with view and scope. And starting with the simple idea that you can add receivers with modifier, we can actually take it further in a completely new dimension, which interacts well with other Kotlin features like inline functions. How it's related to inline functions? Let's take a look to this typical problem on server side, where you have some context, for example, transaction context, and you want to wrap a block of code into transaction context. You want to start transaction, do some block of code, and commit transaction. And in Kotlin, you write this as an inline function. You take its higher order function, takes a block of code, and it wraps it into whatever scaffolding you need. With this high order function, how you use it? You write function, and inside of it you say with transaction, and that's your code inside it that is wrapped. The great thing about this usage, it has no magic. Like any person who sees this code immediately understands that there is some function called here, and they can click the code, see what this function does, see that it starts transaction, ends transaction. Contrast this with how it's usually done with annotations. You annotate, function with some annotation, and that's magically performs this wrapping in non-transparent way. So, but here's also a downside of it. The downside of this is now your code is nested to the right, and as more of those things you add, the more code becomes nested to the side. So what if instead of this kind of use size syntax, we've introduced the concept of decorator? What if we could say that you mark a function with a decorator modifier, and when this function becomes a decorator, instead of nesting your code inside of it, you can now use it as if it was an annotation. You can just write with transaction and write your function. This way, your own code is not nested, is not moved to the right, and it gives you the best of two worlds. It gives you concise syntax, and it gives you complete transparency in what it does, because you can always click on this function and see how it's implemented. And of course, the concept of decorator is not new. It's used in many languages extensively. But for Kotlin in particular, it can be implemented statically by a combination of inline functions, and the ability of Kotlin to inline them during compilation. Now you ask how the idea of decorators related to multiple receivers. You see, in fact, that if we start thinking about decorators, we immediately come into a situation where to wrap some code, we might need some outside context. For example, our with transaction decorator might need an external transactional context that it would use to begin and commit transaction. And if a decorator needs additional receiver, it means any code that is decorated with it requires this additional receiver. So by applying this decorator function, we say that now this function requires transactional context to be called in because it is decorated with something that requires transactional context. And by taking this idea, we can, instead of bringing a special syntax to add additional receivers to functions, we can instead start with decorators and then just have a standard library decorator, for example, called with, that the only thing it does is brings additional receiver to the code without doing anything else fancy, like closing researches or committing transactions. So now it's just a standard decoration, a standard decorator, and it's a part of a bigger feature that enables very powerful meta-programming in pure Kotlin code without having to do magic bytecode engineering, post-processing, things like that. But you see, not all features has to go this far. It doesn't mean like every feature that you ask for has to become a part of some very big picture. There are quite straightforward asks that we can find in our UTREC. For example, support for public and private types for a property. It's pretty Kotlin-y problem, and it's highly voted because it rises a lot in Kotlin code. You see, if you look again the issue, you'll see that it gives you a syntax proposal. And in this case, the syntax proposal is quite straightforward. And I hope, just by reading the code on this slide, that it's, value of items, which is mutable list of items, with public getter that returns a list. Like every Kotlin user can immediately recognize what it does. It declares that the public type of this property is list, while its private type is mutable list. And that's one good side of this syntax, that you can understand what it's doing. And the other good side, and it actually solves an important piece of boilerplate in Kotlin, because without this feature in Kotlin, you'll have to create, use this underscore convention. You have to create a private property with a different name, and then create a public property that just to expose it with a different type. So it doesn't mean that the feature is really straightforward, we just take this issue and next day implement it. Even for a simple feature like this, we'll need to do some design. We'll need to figure out corner cases. We'll need to figure out compilation strategies and interaction with other features. But indeed, this particular example is a feature that is pretty straightforward to implement. It requires minimal design. The other very popular and thorny question is a ternary operator. It's pretty high in the list of highest voted issues. It has 80 votes at the time I've looked at it. And right at the subject, it says what people want. They want ternary operator from Java and C, where you use question mark as an if. But here's the problem with this issue. Kotlin already has an if expression. You can write the same thing as you write in Java with full question mark A:B by if expression in Kotlin. So if we add ternary operator to Kotlin, it makes it hard for existing code to decide, like if you write an expression, which one should you use? Should you use ternary operator or should you use if expression? So this creates like insurmountable, code style conundrum. What do you do? How do you recommend people? How do you solve all the battles that will appear, and which is the right in this place? The other problem is that Kotlin consistently uses question mark in the context of nullability. So whenever you see question mark in Kotlin code, it's related to nullity somehow. For example, foo question mark colon B checks foo for null. So by reusing null for Boolean expression, it will make it harder for novices to figure out what's going on because it becomes inconsistent. They will have to learn in what context question mark does what. Arguably for developers who come from Java or C++ background, that's not a problem. They already know ternary operator. But for novices, that's going to be additional barrier in learning the language. So they have to recognize what it really does. And you see, if you look at the ternary and compare it to if expression, you notice that ternary operator is shorter. But this conciseness and less characters you type really plays out for really short and small expressions. For example, when you have like this small Boolean variable like foo in this issue, that's where you can immediately see that writing ternary operator is shorter than writing an if expression. But in real code, it's not something we work with often. In real code, we don't promote using of a lot of Booleans in our APIs. Kotlin strives to enable type-safe API in your code. So you're not using Booleans, you're using type-safe enums and other more richer types to describe your API surface. So in real code, if it's well structured, you will get a lot of Booleans, or if you have Boolean expressions, they will be not just a single variable, but some long ones. And the longer expressions, the difference between if expression and ternary operator is not that apparent. Moreover, if expression versus complex expressions is clearer and easier to read. So all in all, if we take this all together, I mean, it means that we'll have to decline this particular issue. So we won't have ternary operator as it is came to us from Java and C++, because Kotlin already have an if expression for that, all the other problems it would bring if we add. But it doesn't mean we're not hearing that you want to write sometimes you want to write Boolean expressions like this, maybe in a shorter way. So maybe in the future we'll figure something else out, but that would not look like a ternary operator. Not all we think about during language design or plan for the future comes from UTREC issues. There are some things that are part of larger trends. And one of those trends is immutability. It's not like we have a specific issue or give us more immutability. It's what people work with. You see, and I'll show you an example how it appears in practice. So assume we have some subsystem and we keep it state. And we start with keeping it state in a simple mutable class. It's easy to declare in Kotlin. You just write a number of vars. And by being mutable class, it's easy to update. You just assigned its properties, and that's done. You've changed it. But now, here's the problem. If you're writing modern applications, we often use asynchronous data communication, even inside the application. We send our data over, or our states, over asynchronous pipelines, reactive pipelines. So when we do that, and our state is mutable, we cannot just send it, because while it's being transferred over the pipeline, it can change. So we have to copy it and send a copy. This is called a defensive copy. And this defensive copy that you have to do on immutable data is easy to forget, and it's a big source of errors in our modern asynchronous applications. The solution to this that people often employ is to use immutable data. And with Kotlin, this is straightforward. You just change var to val, and your data class becomes immutable. It cannot change anymore. So now, when you send it, even asynchronously, you don't need to copy it, because it wouldn't change. Having done so, though, you've made it harder to change your state, because Kotlin syntax for updating a mutable class like this is quite more verbose than a single update of a mutable class. You have to do copy, you have to list all your variables updates in one place. You cannot use concise operators like plus equals anymore. It's way less convenient than working with immutable data. It creates an impression that immutable data in Kotlin is kind of second class. So the question we ask ourselves here is, can we have cake and eat it too? Can we get safety of immutability with convenience of mutable state? And I mean, surely we can. I mean, we can introduce a new concept of a value-based class. Now, what is a value-based class? A value-based class is a class whose sole state in its values. A class that explicitly disavows its identity. I mean, we say that because the only thing we care about it's the value of the class, the contents of its properties. And it's not a new concept in Kotlin. if you think about it, all the what we call primitives in Java, they're actually not primitives in Kotlin, but they're built-in types like int, long, and even class like string. And actually, most of the classes in Kotlin Standard Library are value-based. And for like built-in classes like int and long, a compiler even enforces this. Like if you try to compare by identity to ints, you get an error that those classes do not have a stable identity. They have an identity when they need to be transferred, for example, into a collection. But it's a transit identity. It's not something you can rely on. And because of that, every time you perform operation on this, you get some new value. And identity is just something immaterial. You don't use it. And so it's not a new concept. And it's natural to extend this concept onto user-defined classes instead of just limiting it to built-in Kotlin classes. And by declaring that class doesn't have a stable identity upfront, we can now add syntactic sugar to make updating of these classes easier. Because programmer said that I'm not going to rely on the identity of the state instance. And compiler can check that you don't accidentally use this identity in, say, identity comparison or other identity-sensitive operations. We can bring syntactic sugar that will let you create a copy of this class without writing all this explicit copying code, but just writing as if you're changing immutable class. So, and this sugar makes it this class as easy to update as a mutable class, but brings all the safety benefits of immutability. So here we go. We can have a cake and eat it too. So by itself, this idea is just an interesting direction in future Kotlin evolution. But it also lets us solve some short-term problem that we have now. And the short-term problem we have now is we need to do something with Kotlin experimental inline classes. And right now, Kotlin experimental inline classes are implemented with the inline modifier before a class. And just this modifier inline is a problem because it would be confusing as soon as Java project Valhalla comes out. And as I told you at the beginning, interoperability with various Java features is very important for Kotlin. So we're looking to the future where Valhalla becomes available and starting to think how you write Kotlin code in this world. And Project Valhalla will introduce a concept of Java inline classes that related but very different concept. By naming another different Kotlin feature inline class will create a lot of confusion. When you can inline class, it will be hard to figure out what's going on, whether it's Valhalla inline class or Kotlin inline class. You'll need to clarify it all the time. We don't want to have this confusion when Valhalla comes out. So we need to think of some different name for that. And the whole idea of value-based class gives us a way out. Instead of having an inline class modifier, we can say that inline class is just a value-based class, which is true because inline classes, as they're implemented now, they don't have a stable identity. They're boxed only when needed, and so their identity changes. And you can do identity comparisons of them. So they are a value-based class. So we can use this val modifier to say that this class doesn't have a stable identity. It's only relies on its value. But we also compile them in some special fashion. We flatten those classes into the other classes. We pass them without boxing to the methods. We return them from methods without boxing. And we can express this with some kind of annotation that basically says optimize away boxes whenever possible. And I don't know how we name this annotation, and I actually don't want even to speculate right now because I want to avoid the same problems we had with inline. So we'd rather announce this name as late as possible, so avoid any future conflict with any other features that will be coming in Java. So we want this name to be unique, so when you see it, you clearly understand there's a Kotlin, specifically Kotlin feature on how Kotlin classes are compiled. It also opens us a road in the future when Valhalla comes out to have something like at JVM inline annotation that would compile your class as Valhalla inline class if you're running on JVM that supports it. So that's the plan. So what else? You see, I've been talking a lot about features that we in Kotlin team looked how we're going to change compiler for this and that, but that's not really a scalable thing. We can't do everything you want. You know, there are lots of domain-specific needs, and each domain that Kotlin is unique. You know, server-side developers have their own needs, front developers another needs, et cetera, et cetera. And for that, we've been working hard in the last few years to really re-architect the whole Kotlin compiler so it works as a consistent and, more importantly, pluggable set of stages. So compiler, when it takes sources, analyzes them, they come through a front end. And if you can write front-end plugins there affecting how declarations are resolved. You can introduce synthetic declarations there. And again, in the past year or more, we've been working hard to unify all the Kotlin backends into a common backend that then later goes to generate code for JVM.js and LVM. So this way, you can write a single backend plugin that affects code generation for this specific piece of code, and it works in all the Kotlin backends on all the platforms. With this architecture that we're working on right now, it is possible to introduce new language features, not as a hard-coded built-in feature, but as a plugin. And take a look at our friends in Google who work on Jetpack Compose. With Jetpack Compose, they have this annotation, composable, that you can add to function to do nice things for reactive and interactive UIs. Make no mistakes, this composable is actually a language feature. It's very much like suspending function. But the only difference from suspending function, it's not hard-coded into the core Kotlin compiler. It's implemented as a compiler plugin. But it's a language feature nonetheless. And we specifically re-architect Kotlin in such a way to make this possible, to enable those domain-specific features to be added as plugins. And it's not the only example. Our friends at Facebook work on differentiable programming for Kotlin, where you can annotate your mathematical function with annotation differentiable, and it creates a code to do automatic differentiation of this code. It's also a language feature, just done as a plugin. As it always comes with features like that, of course, it comes with the whole library of mathematical primitives, matrices, tensors, etc. But at the core of it is this language extension that allows you to automatically derive all the differentials for the code, mathematical code you write. And there is a growing community of people who experiment with Kotlin and writing their own plugin. AeroKT community writing really cool stuff based on Kotlin, new Kotlin compiler architecture. There is Brian Null who writes Parasorts library that you can Google, which is really cool. And you can have your own projects that are written on top of that. It's all experimental right now, but we are really committed to bringing it to stability in the future. So for conclusion, let's recap what we've managed to talk about. I mean, it's been a long talk, I know, and I definitely could not cover everything. So we've talked about our commitment to JVM interoperability. We've talked about namespaces and extensions in Kotlin, multiple receivers and decorators. We've talked about public-private property type churner operator, immutability in the line classes, and other contributions to Kotlin languages. But it's not all we're looking at. What else we're looking at? We're looking at how we can make syntax for algebraic types in Kotlin more concise. We're looking at various data literals, collection, tuples, etc., whether they can be brought to Kotlin in a consistent way. We're looking even more flexible property syntax because properties are core differentiation Kotlin feature. We're looking at our library authors and how we can enable them, give them features to enable more expressive, easier to maintain, and easier to evolve APIs. We're looking at constant evaluation and folding, which is also really popular in UTrack if you look at it, and more. I mean, we're really exploring different roads on how we can evolve Kotlin in the future. And we're looking at you, our community, and what interests you, what problems you face, which are more important for your use cases. So please contribute, tell us what you need, and thanks for listening to the talk, and have a nice Kotlin.